Hi children, I hope you're all right. Right now we're going to study a little bit of physics. That means in science, the part physics of your class 7, chapter 1, the measurement. Now children, nowadays whenever you go to the market or whenever you go to a shop, you always see the things are measured and given to you. You pay money and they also give you the object by measuring. Suppose whatever it is, pulses means dal, rice means chawal, and whatever it is, salt and all those, they are using the measurement system. Now children, you know, in the beginning when the human beings have come on the surface of the earth, they had no idea about the measurement. Because their life used to start with the rise of the sun, that is the dawn, and their life used to be stopped for the day at the dusk when the sun used to go and sun used to set. Slowly and gradually the things changed. Then there was a system which had come, which is known as barter system. That means they have become from the food gatherers to the food producers. And you know, the same people is not producing all the kinds of essential items. Suppose you are producing potato and another friend of yours is producing rice. Then earlier in barter system, there used to be an exchange of the material. That was known as barter system. No measurement was there. I'll give you that much of potato, in lieu of that I want that much of rice. Or else the other objects were there. So this was barter system. And the barter system was totally based on estimation. Right now also the people, experienced people say, one man will come and say, this much of rice is left, sir, please purchase it. Then the gentleman will ask whether you know the weight of this. The man will say, no sir, I have the idea that there may be 2 kgs or 5 kgs or 10 kgs. Then the gentleman says, all right, then you must get that much of money. If the man agrees, then take it. But you know what system is that? This system is known as estimation. What is it? Estimation. Right now, sometimes you play games with your friends. Now, how many marbles are there in your pocket? If you can tell it, I'll give you one. Then you estimate, calculate among your mind and say, there are 10. If your answer matches, then you get them out. It's like that he also does the same way. So this is called estimation. And that was one of the procedure of measurement in the beginning. Then, in the time of the British, you know the British were almost covering more than half the world in various places. And their king was Henry VI. Who was that? Henry VI. Henry VI once said, the length will be, the unit of the length will be a year. What is called? Year, Y-R. What will be the year? He stretched the left hand like this and then said, the span of this from the tip of my nose to the tip of my fingers will be 1 year. Understand? From this tip to the tip of the nose will be 1 year. And as you know, the British people are very, very loyal to their kings, so they started, and it was known as year. Right now also you get year, because that has been changed to, nowadays the system is a system, the meter and all those, but year is still there. Year. 1760 years make 1 mile, like that. And 1 year and 1 meter, the difference is the 1 year, 3 inches will make 1 meter. So that is how the measurement was there. And that was started from the king Henry VI. So measurement of length. Later on the things changed. The SI system had come and meter, millimeter, centimeter, all those have come. We use a standard for this which is known as the unit. You know, a very small unit right now is also measured by, and we say them as millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer, and some more are also there. So these are the things that have gone, and then we have come to know about the measurement of the surface area. Right now, this is the blackboard. You want to measure the surface area. What you have to do? You have to take the measurement of the breadth and measurement of the length and multiply it. When you multiply and get, you must need a unit. So what will be the unit? Any measurement of area will have units as square units. Square units. Now what square units? Suppose I say, as for example, 2 meter in length and breadth is 1.5 meter. What will be the area? Area will be length into breadth. That means 2 into 1.5. That means 3 meter. Now meter will be there? No, because the square unit should be. Because here you are multiplying meter into meter. That means it comes square meter. Square meter. That will be the unit. So any area measurement will bring you the square units. What units? Square units. So like that you can measure the area of the triangle, the area of the square, area of the rectangle, and area of a circle that you can make. And in each cases your unit will be square units. Right now there is a formula for this triangle. Triangle's surface is to be measured by half into base into height. Then for square it is 4 into size. That means the side square. Not 4 into size, it is a side square. If side multiplies twice, the area will be. Here the length and the breadth is there, so length into breadth, square units. And in case of the circle, it will be pi r square. So this is how that is done. Well, now we have some irregular surfaces found over here. How to get the measurement, the area of the irregular surface? So it is very easy that you get a leaf from your surroundings at your home. You can bring the leaf and you can take a graph paper. You know the graph paper. You do the mathematical calculations on the graph paper. What you have to do? You place the leaf on the graph paper and then make a margin of the leaf. After making the margin, you take out the leaf. You take out the leaf. Then how to measure the square? You know the graph paper has the small square units there. Either centimeter square or millimeter square, whatever it is. So you will be counting number of full squares occupied. So you count the number of full squares occupied. And then number 2, number of half and more than half squares occupied. So number of half and more than half squares are occupied. That is also will be counted 1, 2, 3, 4, 5, 6 as you know. Suppose you got a number of full squares occupied 50 and number of half and more than half squares, which is also to be counted as one full, is got 10. Then you do what? You add them to get 25. And what was your square? Centimeter square. So you have 25 centimeter square. That is how you can measure the irregular surface of a leaf. Let us see. Now we will just go for the measurement of the volume. Well, children, now we have to discuss about the measurement of the volume. Now there are some regular objects are there. In the regular objects we have cube, cuboid, cylinder, cone and sphere. There is a diagram. Cube, length, breadth and height equal. Cuboid, length, breadth and height different. And then we have cylinder. This is a cylinder. And then cone, we have the cone and this is the sphere. These are the objects which the surface has been made. Now how? The cube, there are side cube, unit cube, As I told you that in the area the square units will come. For the volume the cubic units will come. And that is why they are called the cube. So unit cube will come. And then for the cuboid length, breadth and height, the unit cube will come. For the cylinder, there is a formula which is known as pi r square h. Because the below part is a circle, that is why pi r square, the area of that, and the h is the height. So that is why pi r square h. And then we have the cone, that is 1/3 pi r square h. Again, 1/3 of the area of the base into the height. And again for the sphere, 4/3 of the pi, and the radius cube will come. And all these will come in this way. The volume of liquid, which is known as the capacity. Volume of liquid is known as the capacity, and that is measured in various kinds of cans is present by the government. Now you see the milkman, the dudwala, milkman comes to your house with a capacitor. Now that capacity can, the capacity can, you ask them to give me 1 liter of milk, and they put that 1 liter of milk, and then they give it to, pour it to your own container. So you can get 1 liter, you can get half liter, you can get 2 liters, you can get like that, anything that you want to. Okay? Now in the that is by the capacity. Capacity and the measuring of all kinds of things, liquid like alcohol, like you have the milk, like any chemicals that is given by the unit is liter or milliliter. Very small words, milliliter, and the larger ones are the liter. Now, measuring the volume of an irregular solid. Well, sometimes we have a measuring cylinder. In measuring cylinder, we measure the liquid. There are ingredients here. You see the measurements are given. Now, what is the difficulty of it? What to know for accurate measurement? That is the looking at the particular level of the liquid. This is known as the parallelix error. And what? When you look, our eyesight goes straight. Then when you see inside this, you see the surface of the liquid is little bit of curve. So you have to either take the measurement of the top or the curve. To do it, you have to place your eye properly and at 90 degree with that of the particular level. Well, children, we are right now to discuss about the capacity of the liquids. That I am just discussing you that the capacity of the liquid is measured by liter and it is smaller than by milliliter. I have discussed about it. Right now you see, I have also discussed how to see the volume of an object in the measuring flask. Now, if you have been given an irregular object like a piece of stone or something, how do you measure the volume of it? It's very simple. Take 2 measuring cylinders of same size and put water in a measuring cylinder. Tie a piece of stone or irregular object and let it dip. Do not touch the bottom. Let it dip into the water. Then you see the initial level of the water was this, and then it is raised to this. So it's very easy. The ingredient number will give you the volume of that object. Earlier it was less, and when it is raised, that much difference will give you the volume of the irregular surface. Irregular surface or irregular object. Irregular object. Now we have to measure now the measuring of the mass and the weight. Now, my dear children, when we go to measure the mass and the weight, then we have to know what is mass and what is weight. Just look at the blackboard. We are to know about the mass. Children, you are studying the science right from class 6, and you have come to know that mass. What is mass? First is mass and then is weight. Now what is mass? Actual amount of matter present in a body is called as a mass. And the mass is fixed. Whether you go to the moon or you even go to the sun, your mass will remain constant, whatever was the mass on the surface of Earth was there, the mass will never change on the moon. Though the gravity of the moon changes, because gravity of the moon is 1/6 of the Earth, yet the mass will not change. Mass will be the same. So that is mass. So what is mass? The actual amount of matter present in the body or an object. Now weight. Weight is nothing but gravitational pull on an object. Gravitational pull on an object. Now each and every object on the surface of the Earth is being pulled by the Earth towards its center. And that is the weight. Now how does it come? So weight equals to mass into gravity. G for gravity. Due to acceleration due to gravity. What is it? Acceleration due to gravity. So mg, actually the mass and the weight. Now what is the SI unit of mass? The SI unit of mass is kg, kilogram. SI unit is kilogram of the mass, and weight of SI unit is weight. The SI unit is Newton. Is denoted by N. Okay? And in CGS system, it is gram, and in CGS system the weight is dyne. The unit of weight is dyne, and 1 Newton equals to 10 to the power 5 dyne. 10 to the power 5 dyne. That is the mass and the weight. So mass is the actual amount of matter present in a body, whether the weight is nothing but the gravitational pull on a particular object, and that is the weight equals to mass into gravity, the acceleration due to gravity that comes over here. Well, the next point which we have to discuss is the weight of a body. Weight of a body is also weight of a body is take weight of a body is like this, can be taken as 1 kgf, kilogram force, equals to 9.8 Newton. 9.8 Newton, and in CGS 1 gf, now it's 1 gf equals to 980 dyne. 980 dyne. This is the calculation. Now measurement of the beam balance. Now when you go to a simple market, purchasing some potato, purchasing some mango and all those, you see the beam balance is used for many of the shopkeepers. Right now also there are very less number of digital balances there. So they use by Pala what is known as beam balance. What is happening? In beam balance, they are putting the weight in one pen or one side, the another side they are putting the weight. So that is why they give you the weight. Now, what will be the principle of this beam balance? The principle is nothing but the equal in both the sides. Then what are the things to, excuse me, what are the things to be measured after? That is, both pens should be of equal mass. The pens are there, on one you put the object, on the other you put the weight. So both will be equal mass. And number two, the equal length of the wire or rope will be there. And then string of the length and the mass will be same. And beam should be horizontal. And the pointer is vertical. And when the pen is empty, when you just put the balance up, the vertical pointer will be exactly at 0. So that is how it is done. In spring balance, we have the spring balance there. It's a small measurement of spring balance we do. In one side there is a hook, and in another side you can cling with something, or on a stick you can just have it. And in spring balance, not very big weight, but some weight you can measure. In the spring balance, it will show you the measurement. As the spring will just be stretched by the weight, and the pointer will go up. The spring balance measure. We have the relationship of mass and weight. That is, I told you already written, that is mass, the weight equals to m into g, that means the acceleration due to gravity. Acceleration due to gravity. Well, let us see the difference between the mass and weight. Well, see, the mass is the quantity of matter that I already told you, and here we have to discuss the questions of the chapters for you. Well, children, we have to discuss about the density. What is density? Density is the mass per unit volume. What is it? The mass per unit volume is known as the density. So we have the density here, and it is mass per unit volume is the definition of the density. So density is mass by volume, that is there. And now units of density. The measurement of density is done by mathematical calculations. That mass by volume, that means if your mass is in kg and the volume will be in the meter cube, so the unit will be kilogram per meter cube. So that is the thing that you are done. Now, right now we have to go for the question answers. Right now we have to go for the question answers. Well, the children, after the chapter is being discussed, we have to go through some numerics. The other question answers of the exercise that you can get in the website of the school, www.bsnes.in. I repeat, you can get all the answers, even these numericals also, but I am going to discuss it once more. You see, question number 1. Question number 1, the base and height of a triangle is 10 cm and 5 cm respectively, find its area. So we know the area of the triangle equals to half into base into height. So this is the triangle, base is 5, 10 and the height is 5. So you have to multiply half into base into height, that is half into 10 into 5, and 2 cancels 5 gets 5, that means 5 into 5, 25 cm square. Second answer, second question. A cube has a side of 4 cm. What is its volume? So you know volume equals to side cube, unit cube. So a cube means side cube, unit is volume cube, that means 4 cube centimeter cube. 4 cube means 4 into 4 into 4, that means 64 centimeter cube. The next third number question, an object has a mass of 100 gram and a volume of 20 cubic centimeter. What is the density? So you know density equals to mass per unit volume. There you see, the given mass is 100 gram and the volume is 20 cc. So density equals to mass by volume, that means 100 by 20 cancellation to get the 5 gram per centimeter cube. That is the answer. Question number 4. Question number 4, an object has a mass of 40,000 kilogram and a volume of 5 cubic meter. What is its density? Again, 40,000 kg is the mass, volume is 5 meter cube, and the density equals to mass by volume, that means the 40,000 by 5 equals to 8,000 kg per meter cube. Question number 5. What is the question number 5? An object has volume of 3 cubic meter and density of 6,000 kilogram per cubic meter. What is its mass? Now, given volume equals to 3 meter cube and density equals to 6,000 kg per meter cube, therefore the mass equals to volume into density. That means the mass is, volume is 3 meter cube and into mass is 6,000 kg per meter cube. So meter cube cancels to get you 18,000 kg is the answer. Well, next is question number 7. Question number 7, a water tank measures 2 meter to 4 meter to 5 meter. What mass of water can it contain if the density of water is 1,000 kg per meter cube? So here, given the volume of the tank is going to be into H, the unit cube, that means 2 into 2 into 5 means 40 meter cube. The mass of water given, so mass of water will be density into volume. Density is given 1,000 kg per meter cube into the volume is 40 meter cube. So meter cube cancels. 1,000 into 40, 40,000 kg is the answer. Now question number 8. In question number 8, we have an object of a mass 20,000 kilogram and a density of 4,000 kilogram per cubic meter. What is its volume? So given mass is 20,000 kg, density is 4,000 kg per meter cube, and the volume equals to mass by density, that is 20,000 by 4,000, gets to get 5,000 kg per meter cube is the answer. Well, number 9. Density of air is 1.3 kg per meter cube. What mass of air contained in a room? 2.5 into 4 into 10 meter there. So you see, density is given 1.3 kg per meter cube. Measure of the room 2.5 meter, 4 meter and 10 meter gives you 100 meter cube. So now mass equals to mass of air equals to density into volume, volume into density. That means 100 into 1.3 kg per meter cube, forming 130 kg. Right now, the next question is a stone of mass 30 gram is placed in a measuring cylinder containing some water. The reading of the water level rises from 50 centimeter cube to 60 centimeter cube. What is the density of the stone? So you see, question number 10, the mass is 30 gram. The rise in water level 50 to 60, that means 10 centimeter cube. 1 centimeter cube equals to 1 ml. And therefore, the density equals to mass by volume. That means 3 by 10 equals to 30 by 10 equals to 3 gram per centimeter cube. Well, number 11. Number 11, a block of wood of mass 12 kg floats in water. The volume of wood is 0.016 meter cube. Find the density of the wood. Well, the given mass of wood block, that is 12 kg, and the volume is 0.016 meter cube. So density equals to mass by volume. That means 12,000. 12 kg means 12,000 gram. And divided 12 by 0.016. So we point cancels to get 1. That is 1, 2, 3 zeros. That means 12,000 by 60. If you cancel 12,000 by 16, you will get 750 kg per meter cube. Do the cancellation slowly and gradually at your home. Well, the next question is a wooden block, a wooden cube of size 5 centimeter. And the volume of the wooden cube will be 5 cube centimeter cube, that is 125 centimeter cube. Now mass given is 87.5 gram. So what is the density? Density equals to mass by volume equals to 87.5 by 125. Point dissolves, so you get 875 by 1250. Gives you 7.5 gram per centimeter cube. Divides you to get 1.4 gram per centimeter cube. So this is how you get the numericals. The children, I think you have gone through the chapter nicely and you understood the chapter, whatever the items were discussed, and again all the numericals has been done, and you would get all the answers right from the MCQ to all the numericals and all the answers in your website www.bsnes.in. Now I think we have gone well and you have understood the chapter. I hope you will go through all these questions and prepare yourself. Today, thank you and have a good day.